They would be designed really well designed in a on a trellis, and you put a tarp underneath, and you get free aerial food. It's a starch crop, so it's a. We call them yam berries, or this is a cinnamon vine. So these are actual little potatoes that you could just cook up, boil, and with butter and salt, and they taste like little potatoes. So this improved varieties of this have a lot of potential for a no-dig starch crop for the Northeast.
That's cool.
Which is pretty amazing. They also have a potential for escaping.
So these are only growing here because of this microphone?
No, these are hardy to northern New Hampshire and Vermont.
But they're not recognized as a above ground starch food. They're not used that way.
No, well, in the this is a tropical plant. In the tropics, it's the tuber that's eaten, and you actually in really really diverse Asian markets, you'll find, and sometimes in regular markets, you'll find a shigar, really perfectly shaped shigar-shaped tuber. It's like straight and about this big around. It's because they grow them in tubes, so they can harvest them easier. They actually, it's a tube that's stuck together that's in halves, and you pull one side of the tube off, and you can harvest the tuber.
Cool.
Because they're really hard. You could dig them for starch. After 3 or 4 years, they're a big starchy tuber. But here, if you design a trellis right, after 3 or 4 years, you could get a couple pounds, 10 pounds of no-dig starch just by shaking the trellis. So that's...
What are they called again?
Cinnamon vine, yam berries. We call them yam berries. It's batatas. It's Dioscorea batatas.
Has anyone else ever called them mountain yam?
Mountain yam. There are tons of yams. There are tons of yams with berries like this. There are some in the tropics that are called air potatoes.
Yeah.
And you'll see one in the greenhouse we have that literally get hanging yams on the vine that are this big. And those have a lot of potential in the tropics. But let's go see all these other cool things.
I think that's the mountain.
You want to push it down a little bit, and then we'll do this. It's always fun to stand somewhere I haven't stand in a while and look, because this lichen is brand new on here. This is all new baby lichen. Look at that. There. That's pretty cool. Creating climate for, and these mushrooms are new too. There's some big ones coming. There's
right here.
Look at that one down there. That's a nice shelf fungus. The diversity of mushrooms are just every year get more and more and more. Here's a little jelly fungus. Never had that before. That's pretty cool. So here is, I think, one of our most successful and productive shade polycultures. Of course, polyculture, the idea being growing plants together to benefit one another rather than compete, to support one another rather than compete, which most ecosystems in the world, that's how plants grow. They're supporting, not competing. They're literally filling the niches where the other plants haven't filled. So we facilitate that in our design. We look at a site, we look at the characteristics, is it dry, is it wet, is it sunny, is it shady, is it crappy soil, is it nice soil, how close is it, relationships, how close is it to the house, how close is it to the path, how close is it to other plantings and patches. So here was, obviously, we wanted tall, shade-tolerant fruiting trees somewhere in the landscape. And here is east rises over there, and then 3/4 of the growing season, you get to this point and you hit shade because the sun's coming across here. So this house, it creates a full shade situation. And pawpaws, we knew we wanted pawpaws. They're one of the few fruits that can fruit in partial shade successfully. So we do hand pollinate some because they don't pollinate themselves very well because they're kind of their pollinator partners are somewhat anachronistic, meaning they evolved and then their partners through evolution died for various reasons. Like so, these pawpaws are. You can consider them. See if I can grab a. Right, here's all this. Gina sees when she wants.
They're gorgeous.
I know. When they're in the sun, they get riper faster. This one here is a little yellow, so you can see the difference. You can see the yellow tint to that, and then this one's a little bit greener. So if I just barely, that's too hard, and this one is just getting soft. If I just give a little bit of tug, so I would not pull a pawpaw off if it didn't come off that easy, because if you pull it off too green, it won't ripen. Typically, we actually are not even doing that. We're letting them fall before we pull them, but I just wanted to show you. See, it's a little yellow there? In 3 days, this will start to ripen for us. There's a little yellow there. You really get to know the intricacies of these plants when you live with them. I also learned that this line right here is the division between the seeds. So if I cut along here, if I cut here, I'm hitting seeds all the way across, or if I cut here. But if I cut here, as you'll see when we eat it, anyway, I'm getting too nerdy here. So the pawpaws, the largest native edible North American fruit. This is, if you consider this a berry, what could eat a berry this big? Like a raspberry, birds eat raspberries. They just poop out the seeds, and you get more raspberries.
A raptor?
Like a bear?
Dead megafauna, yes. So these evolved with ground sloths and mastodons.
Same as the avocados.
So they're no longer in our environment. Neither are the insects that interacted in that anachronistic ecosystem, which means that the carrion flies and beetles, which hung out around dead mastodons and their poop, is no longer here. So their flowers, which attract those insects, aren't really around. What's interesting is, what do you see through the fence right there? Garbage. We actually, I don't know, can you see, how high up can you see a fruit? Almost to the top. We didn't pollinate those, hand pollinate those. I'm finding, and there's some urban pawpaws here that Eric planted 15 years ago. I'm finding those trees in the right locations will be full of fruit because they're next to dumpsters, which is fascinating. Yeah. But if they're in the middle of a field, unless they're self-pollinating varieties, they won't have fruit on them usually.
So a compost pile.
Question for so how did they make it between the 10,000 years between the loss of megafauna and?
Really good question. You have a good mind over there. See these trees here? 1, 2, 3.
Are they cloned?
We did not plant them. They're root suckering.
Oh, there you go.
And they're fruit.
Bam! There's another tree.
Okay,
Bam!
How old is this
Bam!
tree?
This one is 14 years old. We actually successfully transplanted it from another location, which I don't recommend because they're taprooted trees. Unless you can actually get pawpaws now that people are developing them without the taproot, and they actually, if they're developed properly, actually will grow better. But typically they're grown in taproot pots, which that's how I grow them. So I transplanted it here. What's interesting, though, one reason they do this evolutionarily is because they're short-lived edge trees. So, like, or if in a forest, if a tree falls down, they'll wait in the understory, and then with these little guys these are gonna wait here, some of these, until the mama falls down, and then these will, with data, however you want to look at it, and then these will shoot up. Except that one over there, that middle-sized one is a grafted variety. I highly recommend if you have a small space and want. This is a seedling closer to wild type. This is full of seeds. This probably has 10 to 15 seeds per fruit. That one there is improved flavor quality and half the seeds. That's a Peterson. Peterson took 30 years to develop these amazing varieties. One of them being that one, Shenandoah. It has the flavor quality of, like, I vanilla cotton candy
Wow.
or something. And these here are more, you'll taste these ones. These are more like, well, I won't tell you what it is. You can tell me what it is when you taste it. I love the foliage on this tree. It's beautiful. You can just buy this and have them just for fall foliage as far as I'm concerned. The tropical foliage. So I was talking about polycultures. So this is one of our successful incarnations. We have the pawpaw and the overstory. Then we have, along here, we have gooseberries. And then in the understory, under everything, we have a polyculture of seasonal herbs. So we have in the spring, early spring, before the plants leaf out, the trees leaf out, we have ramps or wild leeks, and they come up pretty thick and do really well for that 2-week window when everything else is not leafed out. Then they naturally die back. They're a spring ephemeral, so they're a bulb. They're allium. They die back, and then right as they're dying back, there's toothwort, which is a native wasabi. It's like a horseradish, native ground cover horseradish. And the reason it's called toothwort is because it makes your gums numb if you eat it, which is pretty cool. It's edible. And then that slowly dies back, and then the hog peanut comes in, which is a native nitrogen-fixing ground cover, which if I just dug down a little bit, I could probably get a couple of tubers. We're not really growing it for food, although it is edible, and it has salamanders. We actually do get salamanders now. Just mind-blowing, and snakes. I'll find some from somewhere else. So at the end of these strings, here's one. See, not very. It's more calories spent than found. You can pass that around. That's a ground bean, also called ground. I like the name ground bean better. Ground bean is a nitrogen-fixing. Oh, I could find some nitrogen-fixing nodules. Maybe they're all gone for the year. When they were producing photosynthesis, they were are using photosynthesis in the summer. I went out here and dug, and I actually had nitrogen-fixing nodules on them. You all know what nitrogen-fixing nodules do, right? Yeah. So I don't need to talk about that. Nitrogen, of course, is important because it's a limiting nutrient. And so, long story short, this ground, as soon as the snow thaws, the ground is green again, and green throughout the whole season. And then the tree mulches. And so now we have a cover. So it's always covered, either in dead brown carbon or living green plants. And that's essentially a pattern you want to repeat in your perennial plantings. Is you want to always have that, even actually in your annual systems, which I'm learning more. We'll go see some cover crops I've been doing. Even in your even small annual beds, try to get the ground covered in green as much as possible all year round, because your mineral availability is better. Your microorganisms don't go dormant, and in the spring, if there's been a cover crop recently, the plants you're planting in there will start to grow that much faster because the minerals are already available, because the other plants are already interacting with the microorganisms that your vegetables are going to be also interacting with. So it's pretty cool to think about. This system is teaching you how to be a better annual gardener, vegetable gardener.
So that green growth that you're proposing for a vegetable garden, annual vegetable garden, that doesn't, like a weed,
weeds are actually really good.
Okay, I understand that.
Good as
not to use a catchword.
Yeah,
but the reason people weed supposedly is because there's competition. Yeah, this other ground cover doesn't present that problem.
Really good question. More and more is starting to be research on this. Some of these kind of really advanced and really forward-thinking soil scientists are starting to really question, even in USDA, are starting to really, in RCS, are starting to question the conventional ag model. The problem is in conventional ag, there's so much tillage and chemistry being thrown on the ground that it changes the whole dynamic of the ecosystem, and we get and farmers and growers get stuck in a pattern of killing the soil and then having to add nutrients that the microorganisms would have given, and so it actually skews their perspective of what agriculture is. What I'm learning is if you are able to understand the how does this say? It's the biogeochemical system and the way it works. If the weeds don't compete for light in an annual system, and you have a really healthy, thriving, well-mineralized soil, weeds are actually a benefit to agricultural system, and they actually won't even be there in some cases because the system is so productive in an energetic way, and that the energy, like corn is a very energetic plant. It needs a lot of sun and nitrogen and minerals to get big fast to create really big fruit, like corn. If your biology is offering that and chemistry in your soil is offering that energy, then the weeds can't compete in that highly energetic system, and the corn is preferential to that highly energetic system. So you can actually design agriculture to be energetic that discourages weeds.
Or solitary ground cover.
Yeah. So anyway, that's a long story. I can get really geeky into the soil stuff. Let's go back and see some more exciting polycultures.
Say I
in the back.
accidentally picked one of these other.
You accidentally picked one off in my hands.
So that's an extra one.
Thank you.
It sucks. I think it's heavy.
Pick one up, and then bring it over here, and I'll show you. Here, this is the core of the edible forest garden landscape, or the food forest that we designed. It has elements within it, so like ponds and sheds and greenhouses and trellises, and outdoor rooms and pathways and annual production. But the core of the design was particularly for the geekiness Eric and I wanted to experience, which was the 200 species of plants that we wanted to have in the landscape. Originally it was 300 species, now we're down to like 250. And taking those 200 species of plants and incorporating them into the patches of the landscape that we observed when this was just grass. So we observed different soil types, we observed different sun and shade types, we observed low spots and high spots, we observed viewscape. So we're essentially a courtyard right here. There are people looking in, so that's an effect on the design. We're looking at relationships to the house, so we wanted some things closer and some things farther from the house, which then informed pathways and structures. Like, there's the reason the sheds. Anyone want to guess, using your permaculture goggles, why we put the shed right there? Who wants to guess?
This is someone's backyard right here. The other side is someone's backyard.
Yeah. What are some like core reasons why we would have put the element of the shed right there? So someone said some access. That's good. It's between the kitchen doors and the back of the lot. We knew we were needing to access the tools and materials in there more often. We didn't want to put it in the back because then it would be hard to get to. We wanted to have somewhere in the middle of the landscape. What's another reason why we put it right there rather than over here or
we'll also get sunlight, so chickens might get some warmth.
Okay. Although we did factor in the sun, but when our initial design, we were actually looking at this. In fact, most throughout the growing season, this is a full shade spot. So, what is one more thing you think why we put it there rather than somewhere else? Is that a Norway maple? It is a Norway maple.
Factor in allelopathy?
Okay, so not necessarily allelopathy, but soil conditions. That was some of the crappiest soil on the landscape. So crappy soil, shade, next to the door of the house was a perfect place to plant a shed. So that's why we put it there. And it's in the north. If we put it in the south edge, there's a potential for shading other things. So shade, crappy soil, and access were the main reasons. So we did that with every element. So pond was, we wanted a pond. We wanted to enjoy the pond. So we wanted it near the doors. It's a low spot on the landscape. This happened to be the lowest spot when we did our observation. This is the most puddling was happening right here. And we knew we could, and the pathways from the two doors, amazing. The door from the greenhouse was obviously going to be a main pathway because we're going to go between the greenhouse and the house a lot. So once that was established, it established these two paths because it's a direct path from that door to this path. It created this triangle right where the lowest spot was, so obviously in the crappiest soil. So crappy soil, lowest spot says pond next to a house. That was one of our goals too. Otherwise, it could be something else if we didn't have pond as a goal. But so that's how we did all the elements. Is like the landscape. Once we had our observations and we had our goals, we matched them up. We knew where things went essentially. We knew we wanted a hardy kiwi. We didn't want to put the hardy kiwi on the other side of the lot because then we would never go get the fruit. We wanted to be able to just pick it when we saw it ripe. So near the house, we knew we wanted some outdoor rooms, and we knew we wanted to reduce the intensity of the sun in the summertime. This is where the sun is, at 1 or 2 o'clock. So this gets intense sun at that time of the year. So we created a shade, and this is one of the shadiest, nicest, coolest spots on the landscape now because of the kiwi. By looking at the landscape and matching it with our goals, it became obvious this is where the kiwi arbor went. And we just kept doing that over and over and over and over and over, and things just kept popping out. I could talk about the persimmon in the same way. Persimmon, it's a 40-foot tall tree. I'm curious to see if it goes after the persimmon because I haven't witnessed it yet, eat fruit yet from that tree. But that's a 40-foot tall tree, and we don't want to put that over here because then everything behind it will be shaded. Persimmons can live in crappy soil. That was some of the crappiest soil. Persimmons, this particular persimmon, you eat it when it's ripe, when it falls, not off the tree. So this is an American persimmon. Yep. Wow. Can you all see just look to see if that squirrel grabs the fruit? I'm just curious to see if it's eating our fruit or not. I don't think we haven't seen it yet do it, but.
Did he go up the tree?
It had an acorn?
Some kind of nut.
Okay, good. You can eat as many acorns as you want, buddy. We knew this time of year, the fruit drop, we didn't want it to be thick thick understory growing, something thick like this. It would fall in there, you wouldn't be able to see it. So we did the understory the best we could so that we knew at this time of year the herbs would be fairly dying back or getting brown. And it's also near the house. If it was falling over there, we would never get the slugs and the insects would get it first. Here, I've been coming out every morning and getting 2 big handfuls of fruit, which we'll be eating here in a minute. And so you can just get the idea, the patterns, how they flow and how they're designed is. And once you have the keystone, which is the persimmon, and you have another 30 species that fit this patch that you want, you can design them underneath the keystone tree. So we have mulberry, which is that tree there, another edible fruit that can take partial shade. And then behind it, that thing with the sticks is actually a gumi bush, which is a shade-tolerant, nitrogen-fixing shrub that has delicious, sweet, tart berries that look like little cherries in the springtime. It's right around strawberry season. They start to ripen, and they can take this. This was full of fruit, and what's neat is that since it's an understory shrub, it actually leaves out and flowers before the other things are leafed out. So it actually, even though it looks like it's covered in tree right now and shaded out, it actually does most of its production before the other two trees leaf out. And so it's actually in a perfect spot.
It's deciduous.
It is deciduous, yep. It's an autumn olive relative.
Have you been getting mulberries?
Yeah, this thing was covered.
Was it?
As productive as a full-size mulberry tree, and it's a dwarf.
What's the variety?
It's a Drawley dwarf from Edible Landscaping. I don't know if he sells them anymore.
No.
Unfortunately.
I talked to Eric about another dwarf, and I want to check and see if it may have been.
I think you
Just tell
might
me
about
about
this one. Yeah.
Yeah.
EdibleLandscaping.com.
Okay.
He might have other ones at this point that are
Yeah.
maybe even better. Or if you do get it on dwarfing rootstock, there's better varieties than this.
Okay.
For sure. Any questions up to this point about the elements that we've talked about? Or any of the plantings?
Or water catchment going?
Good question. No.
So how does the pond get full?
Just straight up rain on the water itself fills it up, but also this is the lowest spot, so during heavy rains there will be some infiltration from the landscape, but mostly because of the rocks and it's a little bit bermed up, it actually doesn't get much water from the landscape. The landscape sloped exactly opposite of what we needed for water catchment. So when we go to the back in a little bit, if you look forward, there's about a 3 to 5 foot fall going towards the street. And it's barely noticeable when you're standing like right here, but it literally all the water rushes in this direction. Plus the gutters, the main source of water catchment for us is the house. All the gutters are pointed downhill toward the street. You know, that's how urban designers design, is they want water away, down in the sewer, into the river, into the ocean. They don't want it in a pond, in a tank, in the ground, feeding your plants. If I could do it over, I would, and if I had the money, I would dig up this driveway and put 10,000 gallon drums in the tanks in the driveway. And to make it affordable, I would make it drinkable, so that we could filter it and have it clean system, so that we're just not irrigating, which is expensive, 10,000 gallon. When we can pay for cheaper city water, it would be an expense to pump our own expensive. But if you're drinking it, that's a whole nother thing. We do have irrigation. Unfortunately, that's on city right now, but we're using micro sprinklers and drip irrigation. So a lot. And this year it was the first year we didn't do any irrigation, both because it happened to be a wet year, but also because we have a new philosophy in that when the system is established like this, the plants actually will become more resilient the less you water, because the root systems are forced, and the mycelium, the mycorrhizal associations will force the roots down to get more water. If you're babying them and watering on the surface, all the roots will be up. And so during a drought, if all your roots are up and you don't irrigate, things die, and that's what can happen. So this year is the first year I learned. Not only it happened to be a wet year, but I think from now on, I think we're gonna wait a month before we irrigate. In most cases, if something's really wilty, and we know it has a tendency to die off, we might irrigate it, but sure. I could talk a little bit about our annual system. So this is called a keyhole bed. This is not supposed to be here. I think the kids put that there. So if you've never seen a keyhole, maybe you've only seen it in a book. But a keyhole is an area of production where instead of doing a pathway that goes all the way through, you stop it at some point so you can still access everything from all angles, and then you actually increase your growing area. So that pathway now becomes growing area. So we have it changes. This area is somewhat experimental, somewhat edible, but this year we put in this is a new one for us. This is native water parsnip, which is our native skirt, which has an edible root like a parsnip. And it has umbel flowers, Apiaceae, so it attracts beneficial insects. So we wanted to use this little space that we had. Instead of taking up space somewhere else, this is a rotational space, so we're trialing it for a year here to see if we want to have it or not. So you've taken what would have been a path and you've created productivity. This is my example of our new cover cropping method. This is a 3-species cover crop. Let me see if who can name them all.
Peas, oats, and radish.
Close.
Zoom? Or Spooner?
Every tour now I'm pulling one of these. Eventually we're not going to have any more. But think of the people you're educating. Yes.
Daikon?
Daikon. So peas for nitrogen, rye for carbon and allelopathic weed suppression, and daikon for tillage. So this root here, the daikon will be about a third or a quarter of the root mass. It'll actually eventually get about as long as this root is and thick like a carrot. But then this will continue to grow. This taproot will continue to grow as much as 6 feet as an annual, a short. I mean, I got this in a little late, so it probably won't get that big for us because I think by 20 degrees it'll winter kill, or maybe 15 degrees it'll winter kill. So with these 3 species, annual cover crops, you're getting tillage and mineralization because mustard family has a potential to accumulate minerals. You get weed suppression, carbon production, and a spring cover crop because this one won't winter kill. This will stay alive. And then you get nitrogen fixation all in one round. And this is actually low diversity. There's people now doing 30 species of cover crops together. And I'm actually learning, this year has taught me that diversity is key in our growing systems. So the more diversity you can incorporate into any of your growing, the better. The diversity of minerals is increased because those organisms are accumulating and working the soil differently to find different minerals. So for us, it turned out that the geekiness, the original intent was to be geeks around planting. Maximizing diversity for us was more of can you do it and how can you do it rather than should it be done. But it was an accident, I think, that 200 species of plants actually built the best soil we could have built for the last 10 years. We have almost perfect soil after crap, pretty much. It's crap.
What's the goal for a bed like this then? The rye will be perennial.
Yes. Yes.
The other two will die.
Yes.
So what would you do after a year of this? Would you just plant some perennial?
So it's part of the rotation. So the goal here is to keep as much stuff growing throughout the year as possible. This is the off year for food production, the off period. So there's a number of ways you can go. Whether it works or not, I threw in some garlic bulbules in the mix. Did anyone ever plant garlic bulbules? So sometimes garlic, if you let it the scape go, it'll actually create little garlics on the top. Some I don't know if that's hard neck or soft neck. I can't remember what does that. Maybe we did that. So you throw those down, and what happens in the spring? You get spring garlic, green garlic. It doesn't create bulb, but you can eat the tops like a scallion, essentially. So, assuming that this cover crop isn't killing it, once this gets winter killed, I'll actually see some little garlics coming up. And by spring, those will be full-on green garlics. And then that's our first crop. And then that will be pulled out maybe May. We'll be eating it through up until May. And then once the ground warms up enough, this might go into tomatoes.
And the rye will still be growing.
We'll probably have to figure out something to do. We'll either sheet mulch it or we'll try to cut it out, but we probably won't till it or pull it out. We'll see.
Because the rye would be a shade crop.
But it could interfere with the roots of the tomatoes.
It could. It's a little allelopathic. But I don't know. For us, it's an ongoing experiment. I actually want to see what we can do.
And after a few years of that, then you put all cover crop back.
No. We'll do a season of whatever crop it is. So we had a potential spring crop. It could even be greens like mustards and lettuces, which I did over here last spring. After tomatoes, either put it into another diverse cover crop, maybe even put the cover crop into the tomatoes as it's maturing. You can actually then cover crop in. And as the tomatoes come out, that cover crop's already filling in. Or some other ground cover that's useful. At that point, I could sow in a mix of hardy greens. Tomatoes come out, hardy greens for another 2 months. And then the hardy greens come out, and maybe then we could even rest it. It's okay to rest it sometimes. We would maybe put it into compost and straw for a winter or something. Or we could seed in amongst the greens carrots. Pull all the greens out. The carrots are hardy. If they get big enough, they'll overwinter in the ground, and we can eat carrots throughout the winter. I've actually, in this bed 2 years ago, I did it. We got some of the best carrots ever, and the ground didn't freeze very solid that year, and I was eating carrots out of the ground the whole winter. So there's a lot of diverse ways of treating your annual beds than just saying, okay, tomatoes, maybe tomatoes again next year. Okay, maybe I'll do squash next year. The next year, that's how we were doing it. We were like, okay, tomatoes. Maybe we won't do tomatoes there, tomato family there again. Maybe we'll do garlic the next year, but now we're like, I'm like getting into this like every 2 months, what's going in there, you know? Yeah.
Did you just broadcast the seed and like you're just create a mixture and just
yeah?
broadcast
That's a good
it all
question. So
together?
I have this is my particular treatment. So I take care of whatever green. Sometimes these beds actually go to weeds and we ignore them and they're just dormant or they're in fallow. There's a couple fallows over there. I'll show you in a minute. So I think this one was in fallow. I think we got. What happened was we got the sweet potatoes in late. We had a cold year. Sweet potatoes sucked. Didn't do anything. We let the weeds grow up around them. Ignored it. So what I do in that case, or if it's just another crop, I'll pull the crop or the weeds out, or mulch them right there. Sometimes I'll come in with my broad fork and just aerate it, not till it. Then I'll put down. Then I'll get out all the rough material. I'll put down minerals, compost. I'll seed in whatever it is. I'll water it, then I'll mulch it. And that's how I got this. And so, anyone here never seen a broad fork? Everyone's seen a broad fork? Sure. Okay.
Roy has it. You should show him.
I'm not sure.
You've probably never seen this broad fork.
Yeah, it's different.
Come look.
I'll bring it out.
Oh, yeah, I've never seen one of those.
Now you need one.
Belongs in a tractor.
Don't use a barefoot.
I have a couple you can borrow, Roy.
So this is a meadow creature. Broad fork, brand name. Meadow creature. Yep. It was designed for the Pacific Northwest. They have really, really hard compacted, at least in certain areas, hard compacted clay. So this is for hard compacted clay. It also is designed to never break. That's why we like it. And essentially you get on it and you can just do it right over here for a minute. Next here, there's. And so if you get going on this, it gets pretty effective, especially if it's already been broad fork once before. So if I go in this bed now, it takes me 2 minutes to do the whole thing. And because we have such compacted subsoil just under our nice beds, I'm doing it almost every year just to try to get that compaction up because it's compacted clay and sand. It's like a clay layer and then there's a sand layer and it's just like this mess down there. There's some asphalt and concrete mixed in. But you don't want to do this after you plant your perennial system, because then things like persimmons will shoot from broken roots. Like we felt like we needed to do it. So that we broad forked after the fact, and that was a bad idea. Because now the persimmon there's persimmons all over there that are coming up.
For sale.
So, what do we got for time? Like a half hour? 20 minutes?
It's 12:15.
Let's just do a tour around the back so I can just point out some things. So here's another pawpaw. You can see that the pattern of perennial polycultures is repeated. So we have gooseberry, in this case, pawpaw, and ground cover comfrey underneath. Here's another repeat. This is jostaberry with some other things like this is garlic chives, strawberries over there. This is this little tear-shaped bed had a lot of iterations over the years. We finally settled on a all-year flowering bed. We didn't feel like we had enough flowers in the system, diverse enough amounts of flowers in the system. So we wanted to focus on some diverse flowering system. So we have an understory of this is green and gold, which is a native aster ground cover. It's important to have things like asters and umbels and apiaceae in your system. So that's the carrot family and the sunflower family. You maybe talk a little bit about this in your class, but the little teeny flowers that can, the small mouth parts of small insects can get in there and eat the nectar, and then they parasitize your pests for you. We can go in the greenhouse if it starts to rain too much. But there's a diverse mix of also the third family is the mountain mint family. So you have asters, mountain mints, and carrot relatives. And if you can do it so that they're flowering at different times of the year, you're encouraging your beneficials to stay here rather than go somewhere else. That means the pest control is that much more powerful. On that note, in general, with this kind of patchy, foresty design, diverse plantings, we have very little pests and diseases. So we don't spray, we don't use herbicides or pesticides in general. This year, for the first time, we sprayed pyrethrin for we got the cutworm on the gooseberries. If anyone you've ever seen it before, it can defoliate a gooseberry bush in days. So that's one of our favorite fruits, and we have a lot of it. So to have a pest like that in our system, it's bad. And the reason it's a pest is because it's not parasitized by wasps. It's actually a maggot that acts like a caterpillar. It's a fly maggot that acts like a caterpillar. It's camouflaged so you can't see it, and it's really smart. It will drop off the leaf if you touch it. It actually wiggles, so it scares things away when it gets touched. And it's really resistant to some herbicides. Like I tried neem, it didn't work very well. Pyrethrin's a little bit more powerful. It's a natural pesticide, but it is poisonous. So we only target, as soon as we see them, we target once, a one-time application only on the gooseberries, and so it's a very targeted insect control. That's really the only major pest that we've had. Trialing some things here. We knew we wanted bamboo. Where were we going to put the bamboo? We knew it was going to get tall, so we wanted it toward the back of the landscape. We knew that it was somewhat evergreen, so we wanted it to potentially be a windbreak. So this back west northwest corner turned out to be the best place for it along the fence. It doesn't take up a lot of space. It screens about 40 windows looking into this corner. The only window now, if I'm standing here, is that one right there. So we're going down from 40 to 1 is pretty good. These are edible varieties, so there are 3 varieties of Phallostachys bamboo. They are runners, so we do need to put in a bamboo rhizome barrier. This goes down 2 feet, this piece of plastic here. It is functioning at about 80%.
So what would you do? What would you do differently?
So when I say that, it really should be 100%. The whole idea of a barrier is to keep it out. But 2 reasons. One is it was installed improperly. It needs to be another 6 inches above the soil line. It was planted at soil line, so it's jumping over. So what happens with bamboo, literally the bamboo gets so robust and thick, it can push the plastic over. So that's what it's doing. It's literally pushing the plastic over and jumping over.